Good morning, everybody. Good morning. I don't know whether you can hear me or not. Please unmute your mic if you are speaking, and then please turn on the cameras. It is time for us to begin now. Okay, welcome back, everyone. So we are still working on equations. Okay, we are looking at several different ways of solving quadratic equations. We completed that in previous class. So today we'll be working on the applications of quadratic equations. So as you have seen in the previous class, what we normally do is we don't try to solve so many questions. Instead, we are going to look at few questions and then try to develop the fundamental concept out of it. Okay, so we are going to do the same thing here. We'll not be solving so many questions on applications. We'll solve few questions on applications, but we'll try to solidify the concept of using the quadratic equation to solve some of the real world problem. When we say real world problem, when you start working on your mastery exercise later on, or the problem from your textbook, question in the exam or quiz at your school, you'll see that the questions will be very different every single time. But the concept, the fundamental concept, will always remain the same. So whenever you are solving the real world problem or the word problem in mathematics, the key is to read through the problem in detail and then solve it. Okay, so here our goal is to make you ready to solve the real world problem involving the quadratic equation. That's what we are doing today. So as you have seen here, we are learning mathematics through concept and examples. Definitely we'll be using example to solidify the concept. So this is going to be our first example. So please copy this question and we'll start talking about it. Make sure you keep your cameras turned on. Don't forget that. Okay, I hope you are done copying it. Now let's start talking about it. So as I said before, the first thing that we have to do is read the question and then understand the question. Okay, so here the question says the sum of reciprocals. You can see there are a couple of words there. So if you see some important word, you can highlight them. So the first word there is the reciprocal. Okay, the sum of the reciprocals of two consecutive, second word there, consecutive even numbers is 7/24. You have to find the numbers. So when you look at this question that has only two sentences, it already had three important words there. Okay, three important words. So if we know these three words, it is quite easy for us to solve this equation. I should say to set up the equation. To solving is another part. Okay, solving may or may not be that easy. So what do you mean by reciprocal? What do you think is reciprocal? Diksha, what do you think is reciprocals? Please unmute yourself, Diksha.
No, I was talking to my dad.
Okay, you don't know what is reciprocal. Let's see. Let me check with Sagar. Sagar, what do you think are reciprocals? You can give some example. You don't have to define. You can give me example and explain it.
I think it's when you have to like switch so like when you're doing an equation and you have to switch the number, the denominator and the denominator, and then multiply.
Okay, you're talking more about the concept there. Okay, let's see. Let's check with Aditi. What do you think are reciprocals? You can give example to explain it.
I don't know.
You don't know? Okay, Diksha in the chat says opposite. Opposites are negative, by the way. Let me check with Chandana. Can you give me an example to explain what reciprocals are?
So if we have 3, that could also be considered 3/1. So the reciprocal of that would be 1/3.
That is very true. Okay, so opposite is different. Okay, some of you are talking about opposite in the chat. So yes, Chandana, you are right. For example, if you have a number 3, then the reciprocal of 3 is 3 means 3/1. Okay, when we say 3, 3 is same as 3/1. So the reciprocal will be 1/3. Okay, reciprocal means 1/3. Similarly, if you have a number, say for example 4/3, reciprocal of 4/3 will be 3/4. 3/4. So when we say reciprocal, if we have a fraction and if we switch the fraction or if we flip the fraction, if we flip the numerator and denominator of the fraction, then that will produce the reciprocal. Okay. So that is one important thing to know here in this question. Second thing we have is consecutive. See, here we are talking about consecutive even numbers. So before we go to consecutive, let me check with Pooja. What are even numbers? Pooja? You can unmute yourself and then speak. Okay, Pooja is typing here. Even numbers are numbers like 2, 4, and so on and so forth. Okay, got it, Pooja. That's right. So the numbers like 2, 4, 6, 8, which are divisible by 2, they are called the even numbers. That's very true. Next, we have in the same, so we know even numbers. In the same question, we have the other word here, consecutive even numbers. Kavya, what do you think are consecutive numbers? You can unmute yourself better. Yeah. Okay.
Consistent even numbers. Consistent, like they're consistent.
You think they are consistent? Okay. Thank you. Let's check with Karina. Karina, what are consecutive numbers?
They continue, like the following number continues.
Right, the number that come one after another, right? After, for example, if we are talking about the consecutive even numbers, then we are talking about numbers like 2. Okay, let me write here 2, then 4, then 6, and 8, one after another. We are not skipping any. If we write 2 and 6, these are also even. 2 and 6 are even, but these are not consecutive. Okay, the number that follow one after another. If I write 10 and 12, they are continuously even, right? There is no even number in between. So that is the meaning of consecutive. Okay, the number that follow one after another. And you can also see that if they are consecutive number, if the first number is 10, second number is 2 more than that. The next number will be 14, which is also 2 more than that. Okay, so this is the basic thing that we should know in this question before we even begin to solve this. Okay, now we can begin. So we have the idea of the basic words. Now we are going to solve them. Okay, so here we are talking about the sum of the reciprocals of 2 consecutive even numbers. So we are talking about 2 numbers here. We have to find the numbers. So we don't know what the numbers are. So we are going to assume these numbers. So that should be the first step. So let's write that down. Let the numbers be x. If I don't know the first number, then I can call it x. That means the second number will be 2 more than that. So x plus 2. So the numbers are x and x plus 2. Now, after this, you can see the sum of reciprocals. So we can form equation here. Sum means you have to add, right? Sum of the reciprocals of consecutive even numbers. So reciprocal of x, as we have said before, reciprocal of x will be 1 over x plus the reciprocal of second number is 1 over x plus 2. Okay, the sum of the reciprocals, that's how we add the reciprocals. Sum of the reciprocals is equal to 7 over 24, right? This is equal to 7 over 24. So you can see that we form equation here, okay? With the help of the equation, with the help of the question, we are able to change the question to form an equation. Now we need to solve this equation. Please note something. We are working on the application of quadratic equation. So somewhere down the road, when we are working on this one, we'll get a quadratic equation. Keep that in mind. Okay. But here we got equation with fraction. If you remember the first day of our class, we work on equation involving fraction. And what we did is, in order to solve the equation involving fraction, we have to multiply each term of the equation by the LCD, the least common denominator, right? We have to multiply throughout by least common denominator. So in this case, the least common denominator will be, you can see here, there are different numbers. They are not the same. There is x as the first denominator. Second denominator is x plus 2. The third is 24. If you have all different numbers or all different values in the denominator, your LCD will be the product of those. Product means we multiply. So 24 times x is 24x. And then also we have to multiply that with x plus 2. So the LCD will be 24x times x plus 2. So what we are going to do is, in next step, we are going to multiply each term of this equation by 24x times x plus 2. So let's write that down. So in next step, 24x times x plus 2 should multiply the first term, 1 over x. Then plus, it should also multiply the second term, 24x times x plus 2, multiplied to the second term, which is 1 over x plus 2, equal to, on the right, we have 7 over 24. We also have to multiply that by 24x times x plus 2. And you already know why we multiply by this. If we multiply by this, in next step, we'll not have the fraction. We'll remove the fraction after this step. So let's see how the fraction will be removed. So this will give you, check here. Here is x in the denominator, all eyes on the screen now. Here is x in the denominator, here is x in the numerator. So these two x will get canceled. So if we cancel those two x, when you divide, you can cancel them, right? What we have is, or what is left there is 24 times x plus 2. 24 times x plus 2. No more fraction in the first term. Similarly, if you look at the second term, there is x plus 2 in the numerator and x plus 2 in the denominator. So x plus 2 get canceled. So when you cancel those x plus 2, what you are left with is 24x, right? 24x equal to, now on the right, you can see there is 24 in the denominator and 24 in the numerator. So those two 24s, they get canceled and you have 7 times, here is x, 7 times x, and inside the parenthesis, x plus 2. 7 times x, and inside the parenthesis, x plus 2. So you can clearly see here in the first step, we had the equation with fraction. Okay, in the first step, we had equation with fraction. After we multiply each term of the equation by the least common denominator, LCD, we obtain the equation without fraction. So if we multiply the equation, if we multiply each term of the equation by LCD, we'll be able to remove the denominator, and it will be easy for you to solve after that. Okay, so let's continue this. In the first term, you can distribute that 24x, and then 24 times 2 is a 48. Also, there is a 24x there, equal to, on the right side, 7x times x, 7x is squared. We are distributing there also. 7x multiplied to 2 is a 14x. So now what I'm going to do is, because we have this square term on the right-hand side, I'm going to move everything on the right-hand side. I want to keep 0 on the left-hand side and move everything on the right-hand side. So look at this step very carefully. So here I have 7x squared on the right. Okay. Then we have 14x on the right. Now look at the left-hand side. Here is 24x plus 24x. That is a 48x, right? If we move this 48x to the other side, it will be minus 48x. Okay. And then if we move this positive 48 to the other side, it will be negative 48. So I'm trying to keep one side of the equation as 0. Okay. I'm keeping one side of the equation 0 because in quadratic equation, we can make one side 0 because that is the standard form. Okay. So now what I'm getting there is, if we look at that right-hand side carefully, here is 7x squared. 7x squared. And then here we have 14x minus 48x. 14 minus 48 is a negative 34. So that is negative 34x. And then here you have minus 48. And if you look carefully, all this quantity, this one is equal to 0. So you can write 0 first or after, it really doesn't matter. So equal to 0. So if you look at this carefully, what you'll see is here we got quadratic equation. Look at that. We got quadratic equation 7x squared minus 34x minus 48 equal to 0. Okay, we are working on quadratic equation. We got the quadratic equation. Now we need to solve this quadratic equation. When you solve quadratic equation, you can solve by any method because we have seen several different methods, right? You can do it by factoring, you can do it by completing a square, you can use a square root property, you can use quadratic formula. You have seen several methods. So it is up to you how you are going to solve it. But what I'm going to do is I'm going to show you by factoring method. Okay, because factoring method was the first method we have done. So there are chances that we have forgotten factoring. So we are going to revisit that. So before we solve this one, do you have any questions so far? Okay, look like there is no question. Okay, then let's try to solve this. As I said, I'm going to solve this by factoring. What we do in factoring is, if you remember, we multiply the first and the last term in the equation. So it will be 7 times negative 48. You can also use your calculator to multiply if you want. 7 times negative 48 is negative 336. Make sure you check it because I'm just using my head to multiply. Maybe my brain is working so far. Early in the morning, sometimes it freezes, it's cold here. Now you have to find two factors of negative 336 that will add up to negative 34. Okay, what are the factors of negative 336 that will add up to negative 34? You have to find those two numbers. Maybe those two numbers are 8 and negative 42. Make sure you check it. See, 8 times negative 42 is negative 336. And also 8 minus 42 is negative 34, right? So these are the two required numbers. And if you remember the factoring process, what you do in next step is, instead of this negative 34x, look at the screen, instead of this negative 34x, what we'll write is 8x minus 42x. That will be negative 34x. Okay, that's how we do the factoring. So what we'll write here is 7x squared plus 8x minus 42x minus 48 equal to 0. That was the factoring technique, if you remember, from the first day of quadratic equation. Maybe the third day of our class. Now, when we have 4 terms, what we do is we make 2 groups and factor it. We make 2 groups like this and we factor it. In the first group, you can see you have 7x squared plus 8x. That means the common factor is a x. So when you factor x, x times 7x is 7x squared, x times 8 is 8x, like that, right? And then in the second group, there is a negative sign there. That means you'll factor out a negative number. If there is a plus, you'll factor out plus. If there is minus, you'll factor out minus. And there is 42x and 48. That means the common factor is the 6, right? 6 is the highest common factor. 6 times 7 is 42. And then negative times positive is a negative. So 6, 8, 48. So we still have those 2 groups. If you remember what I said on the first day of the class, if you are factoring right, the quantity that you get inside each parenthesis must be same. Look there, 7x plus 8, 7x plus 8. We are getting the same quantity. Meaning of that is we are doing our factoring right. If we get something else, it will be wrong. Okay. So now 7x plus 8 is common to both. In the first, the remaining factor is x, and in the second, remaining factor is negative 6. So you can see we factored that quadratic equation completely. Okay, we factored the quadratic equation completely. Now, in order to find the value of x, what you have to do is we have to set each of these factors to 0. So if the first factor is 0, let's see what we get. 7x plus 8 equal to 0. And if we set the second to 0, that is x minus 6 equal to 0. Right? To solve the quadratic equation, what we do is we set each factor to 0. That is called the zero product property. And this linear equation, if you solve the first equation, you move 8 over and divide by 7. So you get x equal to negative 8 over 7. From the first equation, we got x equal to negative 8 over 7. But remember the context of the problem. We are looking for 2 consecutive even numbers. We already know that even numbers are numbers like 2, 4, 6, 8, and so on. So this one here, this is not even. Okay? We are looking for even number, but this is not even. This is not even. This is not even. Okay, but if you look at the second now, x minus 6 equal to 0, that means if you solve this one, you'll get x equal to 6. From here, you'll get x equal to 6. X equal to 6, that is the even number. That means this one, the second one, is the correct solution that we are getting. Okay, second one is the correct solution that we are getting. That is the true solution. But this one that you get here, x equal to negative 8 over 7, that is not the correct solution. Sometimes in math, those type of solution are called the extraneous solution. Extraneous solution or extraneous root. These are not the true roots. We solve the equation, we get them as the answer, but they are not the answer to our context. Okay, if we get the result or the root by solving, but it doesn't make sense to our equation, Those type of roots are called extraneous root. I'm slowly introducing this term here because when we start working on something new next week on different types of equation, you'll see a lot of extraneous root there. Okay, so I'm very picky here to select a question where we get extraneous root. So we'll see a lot of extraneous root in upcoming class. Extraneous roots are the roots which we obtain by solving the equation, but it does not satisfy the equation based on our context. Okay, here the context is we are looking for even numbers. So the only number that satisfies the equation is x equal to 6. So now what we are looking for is we are looking for two numbers. If the first number is x or 6, then the other number is 6 plus 2, x plus 2, right? That is 8. So the numbers are 6 and 8. So let's write those down. So required numbers are required numbers are 6 and 8. So those are the answers. We are looking for two consecutive even numbers and we got them. They are 6 and 8. So meaning of that is if we take the reciprocal and add them together, meaning of that is if you do 1 over 6 plus 1 over 8, okay, if you do 1 over 6 and 1 over 8 and add them together, it will be 7 over 24. Okay, you can always check that 1 over 6 plus 1 over 8 will be 7 over 24 because we're looking for two numbers. When you find their reciprocal and add them together, it will be 7 over 24. So this is how we can use quadratic equation to solve the real world problem. When you look at the question has nothing. It has just two sentences. But when you see here, we started with the equation with a fraction. Why I have done that? Because we did equation with fraction at the beginning of this unit when we start working on the equation, right? And then to solve equation like that, what you have to do is we have to multiply throughout by LCD. So I'm trying to review everything that we have covered so far. That's why I've selected question like that. So we get equation with fraction, we multiply by LCD. And when we get here, we got the quadratic equation and we learn how to solve quadratic equation by factoring. So I'm again revisiting that concept here. We have to find two numbers, write the middle term using those two numbers, factor by grouping, right? So the question is selected in such a way that whatever is covered so far is kind of reviewed here in a single problem. Okay, sometimes it is difficult to find a question that helps you go back and review everything in a single sitting, but I have selected question for you like that. Okay, this is the end of this example. Any question on it? Okay, look like you guys are following it, which is great. So we'll do one more question because when you look at the time, you know that it's half an hour. I talk so much, right? Not a good man, huh? Talking too much. Anyways, here is the second question. Please copy this question. Okay, I hope you are done copying it. Now let's work on it. First, we have to read the problem. As I always say, read and understand the problem. That's your first step. So let's see what is going on here. A lot of words. A wire 48 centimeter long is cut into two pieces. Each piece is bent to form a square. What should be the length of each piece of the wire so that the sum of the area of the squares is equal to 80 square centimeter? Okay. So what they are talking about is there is a wire which is 48 centimeter long. So I am going to draw this. Sometimes drawing help us solve the problem. So you can also draw along with me. There is a wire which is 48 centimeter long. 48 centimeter long. And it is cut into two pieces. They have not said where it is cut. That means one piece may be longer than the other. Okay. So let's try to cut here. You should see there. Okay, I'm cutting it here. And we have to find the length of each piece. So out of 48, let's consider that this first piece is X. So I'm going to consider the first piece as X. So this is X. That means the remaining piece will be out of 48. If the first part is X, the second part will be 48 minus X. Second part will be 48 minus X. So for example, what I mean by that is if the total is 48 and if the first part is 8 centimeter, the second part will be 48 minus 8, which will be 40, right? We can subtract to get the second part. That is the meaning. Now what they are saying is after you cut the wire into two pieces, okay, after you cut the wire into two pieces, each piece is bent to form a square. So from this first piece, look at the screen, from this first piece whose length is X, they are bending it to form a square. Suppose that is the first square. Okay. The length of the wire is X. So the total length of this square is X. That means one side is X over 4. Because it is divided into 4 parts, right? The total length is X. Total is X. So length of one side will be 1/4 of that. Because there are 4 sides. Similarly, this second part, look at the screen. The second portion of the wire is this length, which is 48 minus X, the second piece. That is also bent to form the second square. So let's make that a square now. Maybe it is little bigger square when we look at the figure. Suppose that is the second square. Again, the total length of that is the length of all 4 sides of this square, is equal to 48 minus X. That means the length of one side will be 48 minus X divided by 4, because this square has 4 sides. So each side will be the total value divided by 4. Okay, that is what it is done. Now, the question says, if we find the area of the first square and add with the area of the second square, the total will be 80. Sum of the area of the 2 squares is 80. That will be the equation. Before we move on to that equation, are there any questions? No question, okay. So now, to find the area of the square, we have to square the side. Okay, side square will give you the area. So here, the side of this square is X over 4. So the area of this square will be X over 4 quantity squared. That is the area of the first. Plus the area of the second. Here is the second square. So if you try to find that, it will be 48 minus X over 4 quantity squared. So if you square that, you will get the area of the second. Area of the first square. Area of the first square, meaning of that is this one. This is the area, right? Area of the first plus the area of the second. Area of the second is this one. If you add those two, the total area is 80 square centimeters. That's how you can write. So this is the equation. Okay, we obtain the equation. Now we need to simplify this equation to the standard form and then solve it to find the value of x, because we need to find what should be the length of each piece of the wire. Okay. Now, when you solve this, you have to be very careful, and then you have to solve it without missing any steps. So here we have x over 4 squared. This square is for both numerator and denominator. The square of x will be x squared. And then square of 4 is a 16. Okay, that is the first step. Then plus, here in the second one, when you square the numerator, it will be 48 minus x quantity squared. And in the denominator, you have a 4 squared, which is a 16, equal to, on the right-hand side, you have a 80. One more time, this is the equation with the fraction. When you have equation with the fraction, in order to remove the denominator, you have to multiply throughout by LCD. In this case, we just have number 16 in the denominator. That means you can multiply throughout by 16 to remove that denominator. So multiply the first by 16, multiply the second by 16, and also multiply on the right-hand side by 16 like that. So that 16 and 16 cancels in the first term. You get x squared. And then plus in the second again, 16 and 16 cancels. What we have here is, now look at the screen, everybody. What we have here is 48 minus x quantity squared. Meaning of that is 48 minus x times 48 minus x. That is the meaning of that quantity squared. Okay. And on the right, you have 80 times 16. Please multiply that on your calculator. It should be 1,280. 80 multiplied to 16 is 1,280. Okay, now here we have two parentheses. So we need to solve this, or we have to multiply this using FOIL. So let's FOIL them. The first we have 48 times 48. 48 multiplied to 48 is 2304. Next, we have 48 multiplied to negative x, which is negative 48x. Next, negative x multiplied to 48, which is negative 48x. And again, we have negative x times negative x, which is positive x squared, equal to 1280. So what we did there is we FOIL, right? We FOIL, and then we got these terms there. Now all we need to do in next step is to combine the like terms and create that equation. So on the left, everybody look at this screen. Here we have x squared. Here is also x squared. X squared plus x squared is 2x squared. And then here we have negative 48x and negative 48x, which is a negative 96x. Next, here we have 2304. You can see here, look at that number, 2304. And here is 1280. If you move this 1280 to the left-hand side, it will be subtracted. So it will be 2304 minus 1280, because when you move this quantity to the left-hand side, you'll subtract. You can subtract with using your calculator if you want. 2304 minus 1280, that is equal to 1024, equal to 0. So we got the quadratic equation here. See, we did a lot of math. We got the quadratic equation. But remember one thing, if you look at this quadratic equation, here we have a 2. This quantity can be divided by 2. This quantity can also be divided by 2. If you can divide throughout by some number, you can do that and make it a little simple. Okay, you can solve it here. That's totally fine, but it involves big numbers. So we can see that we can divide throughout by 2 and make it a little simple. So let's do that. If we divide this by 2, the first term will be, give me a second here. Okay, so first term will be x squared, because 2x squared divided by 2 is x squared. And then 96 divided by 2 is 48. So 48x. And then plus 1024 divided by 2 is 512, equal to 0. So here we obtain a nice quadratic equation. Look at that. We got a nice quadratic equation, right? So what we are doing is actually we are solving the problem involving quadratic equation. So it doesn't mean that you'll get quadratic equation right here in the beginning. After you do a little bit of algebra, you obtain a quadratic equation, okay? Once you obtain the quadratic equation, you can solve by any method you want. It's totally up to you, but I'm going to solve by factoring, okay? So here, one more time, the coefficient of x squared is 1. 1 times 512 is 512. From 512, you have to find two numbers that will add up to negative 48. So those numbers will be negative 16 and negative 32, because negative 16 times negative 32 is positive 512, and also negative 16 and negative 32 will add up to negative 48. Okay, since the leading coefficient is 1, you can directly write the factors. So the factors will be x minus 16 and x minus 32 equal to 0. So here you can directly write the factors. Everybody note here. Here we can directly write the factors because the leading coefficient, the coefficient of x squared is 1. If the coefficient of x squared is not 1, like in the previous example here, see, here the coefficient of x squared is not 1. If the coefficient of x squared is not 1, then you have to split the middle term into two parts and then factor by grouping, okay? But if the leading coefficient is 1, it is easy to write down the factors directly. Okay, so try to look at this magic here. So when I'm just saying through two examples, okay, I'm saying so much, I'm providing so much information. But when you do problem like this in the school, you have to be very careful. If the leading coefficient is 1, you can directly write the factors. It's easy. If the leading coefficient is not 1, try to split the middle term into two parts and factor by grouping. You'll see that when you are in school, some teachers want to do something called the magic factoring method. They say so on and so forth. Trial and error method. Sometimes it is difficult to comprehend that. Okay, so you can always revisit this video and watch it. It will be posted in the learning management system, so you can watch it. Or if you want to subscribe to my channel for new videos, you can always do that also. Okay, great. So now, see, we got two factors. You can set each of these to 0. The first one is x minus 16 to 0. And the second is x minus, hold on, x minus 32 to 0. And when you solve the first one, you will get x equal to 16 from here. And from the second, you will get x equal to 32. X equal to 16 and x equal to 32. We got two numbers. Now check here. See, the total length of the wire is 48, right? Total length of the wire is 48. If one is 16, the other one will be 48 minus 16. That will be 32. So we already got both of them. Look at that, right? If one is 16, what will be the other? Other one will be 48 minus 16. 48 minus 16 will be 32. Or if you add these two, it will be 48. 16 plus 32, that's a 48. So we got these two lengths. The question was, what should be the length of each piece? So length of each piece will be 16 and 32. So length of each piece are 16 centimeter and 32 centimeter. Those are the two answers. You can also check it if you want. You can always check and verify your work. Let me show you the checking portion here. Everybody look at the board when I'm checking and verifying this answer. See, if the first length is 16, if the total is 16, one side of the square is 16 divided by 4, which is a 4, right? And the area of that square will be 4 squared, right? If the side is 4, the area will be 4 squared. Similarly, for the second, we got 32. 48 minus x, that is 32. 32 divided by 4 is 8. So that means area of the second one is 8 squared. But what it is said is, if we add these two, it should be 80. Let's see. 4 squared is 16. And 8 squared is 64. And 16 plus 84 is 80. Right? 16 plus 84 is 80. So yes, what we have done is correct. Okay, so you can always put the values and then check it if you want, just to make yourself satisfied with the answer you have obtained. Okay, and it is possible with every single math problem. It is possible to check your answer with every single math problem. You could have checked with the previous one also. See, if you look at the previous problem, we got the answer 6 and 8, right? The question says, if you find the reciprocal and add them, it will be 7 over 24. If you find the reciprocal of 6, that will be 1 over 6. If you find the reciprocal of 8, that will be 1 over 8. Right? And then we have to prove that the sum is 7 over 24. If you want to make a common denominator, it will be 24 there. So if you want to make 24, 6 times 4 is 24. So you multiply both numerator and denominator by 4 here. Okay. And 8 times 3 is 24. Here you can multiply both numerator and denominator by 3. So if you do that, you get 1 times 4 is 4 over 6 times 4, 24, plus 3 times 1 is 3, and 8 times 3, 24. Now you can see here, 4 over 24 plus 3 over 24 is a 7 over 24, right? 4 plus 3 is a 7. 7 over 24. So you can always check your answer. Okay, you can always check your answer and then verify that the math you have done is correct. But what you need is, whenever you're solving math problem, one very important thing that I can tell you is you should have the fundamental skills of simplifying the algebraic expression, and you should have a good sense of numbers. That's first thing. Second thing, when you're doing math, you have to be very patient when you're doing the math. You're doing math, you're thinking about something, you want to do something at the same time. Math will not treat you fairly if you do that. Math requires your full attention. Okay, so always keep that in mind. If you give 100% to math, math will give you back 100%. If you're not giving 100%, then math already knows that you are hating math. What I've noticed is, this is funny, but this is quite true. When you hear somebody says, I hate math, when you look at their score, you can see that math is hitting them back. You'll see a lot of people saying, I hate math, and you'll really see that math is hitting them back. It's quite funny, but it's very true. Okay. So with this, we completed the first unit where we talk about equations and linear and quadratic equations. There are several different types of equation. So we'll start working on other types of equation next week. Okay, but we completed the first unit here, which is the linear and quadratic equation. We'll start looking at the other type of equations next week. So today, what you have to do is, after this class, you'll see last 2 examples in your exercise. You need to complete them. Okay, so remember, you can use the concept that we have talked here in the class. If you cannot solve it, then there are videos attached to it, which has a similar type of questions. So watch that video and then solve it. You have multiple attempts. So if you cannot make it right the first time, you can always go back and do it over and over again until you get it right. And I'll keep that learning management system open for you. So whenever you want to go back and revisit the concept, maybe we are in college and you want to go back and revisit, it will be there for you. Okay. So if you continue with this class, if you are not removed from the class, you will be there. and you can always go back and check these videos that we have done here in the class. Okay, and as I said before, there are a lot of videos in the YouTube channel where I'm recording all this. So if you want, you can subscribe the channel and look for the future videos also. Okay, so before we go, what I want you to do is go to the attendance link and complete the attendance.